Okay, today's video talks about the special types or special cases that you get when you are working with the linear systems of equations. So far we've talked about when you get a ordered pair or a point as your solution, and that is all we've done so far. So this video kind of looks at some other scenarios that might happen. So the first thing, like I said, and you'll see the graph to match, and we're going to talk about the description and the number of solutions. So we know when we have two intersecting lines, that is one solution. So you have exactly one solution, and that solution is an ordered pair. Now, I am going to introduce some other terminology when we're talking about these different types of linear systems. The first thing is consistent. So if a system has one or more solutions, it's considered to be consistent. So this would be consistent. And when it has one solution, it's also considered to be independent. So we're going to get used to using those words also. So that was the one we've already discussed. So the next two are kind of new for us. And if you see on the graph, this next example is parallel lines. So the description is we have two parallel lines. And this has no solution. And if you can look, they never touch, so it doesn't ever have a solution. When you're working with no solution, you might when solving, you're going to end up with 0 equals some kind of number, and that's a good hint to know that that's no solution. And because this does not have any solutions, it is considered inconsistent. Because remember, you need one or more to be consistent. So we have one ordered pair, no solution, and the final example is it only looks like we have one line in this graph, but you actually have two lines that are laying on top of each other, directly on top of each other. So that both equations make the same line. And because, well, I'll talk about the solutions first. This actually has infinite solutions. And when you're solving, you're going to end up with 0 equals 0. And the way I like to think about it, if you put those 0 close enough, it almost resembles the infinity sign with the equal sign in the middle. So that's one way to remember infinite solutions. And again, because it has one or more, it's consistent. And this is actually the dependent. Okay, so those are the new cases, the special cases that we're going to talk about. And there's two ways for you to figure out, is this system going to be one solution, multiple, none? And so I'm going to show you the first way on the front of this sheet. Okay, so for the first way, we're going to look at the coefficients of the variables. So if we look at these coefficients, I have 2 over 4, and I have 4 over 3. And 2 over 4 will reduce to 1/2. When these are different, when the coefficients are different, that means we have one solution. One solution, and then you could go ahead and find it if the question asks for you to find it. Okay, so when they're different, it's one solution. Now, if we continue and we look at the coefficients on this next example, 2 over 4 and 4 over 8, these both reduce to 1/2. So that is no solution when they're the same. When they're the same, it's no solution. Okay, so it will take a little bit for you to remember these if this is the way that you're going to figure out what solutions they are. So coincident lines, these are the same lines. And for this, it's important that you're looking for the ratio of the coefficients and the constant. So here we're looking at this, we're looking at this, and we're looking at the constant. So I have 2/4, 4/8, and 5/10. All of these reduce to 1/2. So since all of these are the same, this is infinite solutions. We'll write it over here. Infinite solutions. So that is the initial way to figure out the solutions to these different special cases. If you cannot remember this, there is another way. And if you turn to the back of the sheet, we can now look at these and set it up to solve them, and then we'll see how many solutions. So if I was to solve this, I'm going to do it by elimination. I would multiply this by 2, so I get -2. So I would end up with -6x plus 2y equals -8 is my top, and then my bottom becomes 6x minus 2y equals -14. So now if you notice, both this and this cancel. So I'm left with 0 equals -22, and when I'm left with 0 equals a number, that's no solution. Let's look at my next one. If I do this, I would multiply the top by 3. So I have -3x plus 6y equals -6. And then the bottom stays 3x minus 6y equals 6. So when I look here, this crosses out, this crosses out, and -6 and a +6 cross out. So all I'm left with is 0 equals 0. And again, that is infinite solutions. And we could talk more about that. We know that infinite solution, that's when the lines are the same, so that would be consistent because it has at least one solution, and it's also the dependent. All right, last one. Here, if I'm looking at the examples, my y's are ready, so my y and my y will cross out or eliminate each other. 3 plus 2x is 5x equals 5, and I divide both sides, and I get x equals 1. So now that I know what x is, I know that I'm going to have one solution. I'm going to plug it in like we know how to do, and I get so my one solution is 1, 5. So those are the 3 different cases. I don't care which way. If you can look at the problems and you want to look at the coefficients and you could remember, you know, if it's the different coefficients, one solution, same, it's no solution. If all 3 are the same, it's infinite. Or you can do it like I did here on the back. Well, for your homework, I want you to bring in the note taker, and I want you to complete 1, 2, and 3 on the bottom of this page.